I'm Michael from Neo4j, and I want to invite you to an experiment today. GraphQL is not meant to be a query language for graph databases, but what if we actually tried this experiment? So we combine GraphQL with a graph database, with a real graph database, which has a graph model, a graph data model as its core data model. So it's not like tables and joins, but it's really nodes and relationships. And you can store arbitrary information on each entity and arbitrary information on each relationship. And what would happen if we take this database as a backend and see what we can do by putting GraphQL in front of it? Something that's really cool about the graph database is also something that you might have noticed with GraphQL in general and schema-first development, that whatever you discuss with your colleagues, you put on a whiteboard, is actually what you find in your application graph model again. So you have a really nice language to talk about the entities and their relationships. And the nice thing about the real graph database is this is also what you find in the database. So there's no media break or a mismatch of some kind between the things that you talk about, also with the business people, and the things that are in the database. And of course, Neo4j itself has its own very powerful query language, which is called Cypher, and which is really tailored towards this visual representation of information. But if you leave this aside for a moment, what would it look like if we really do the Neo4j GraphQL thing, as I kind of indicate in this logo here? Of course, you can use Neo4j like any other regular database. Use it as a backend for your GraphQL server, as Will showed here in his Apollo Launchpad example. It's really super simple and straightforward, so it's a no-brainer. But we actually tried this for the last few weeks to work on this to turn Neo4j into a native GraphQL backend. The process is actually pretty simple. You just take the GraphQL query, transform it to your own query language, in our case it's Cypher, execute it against the database, and return the results, right? How hard can it be? The problem is, or one problem we ran into pretty early on is, what do we base this whole query processing on? Because schema, which schema? Because Neo4j is schema-free, so there's no schema. You can put any data in whatever you want, shape you want into the database. So what do? Of course, the whole schema-first paradigm was really helpful and handy here. So we just used GraphQL schemas. So you as an application developer or development team would use your schema and put that into the database, and then we would use that to process your queries and run your queries. And that worked out really well because it aligned the graph model in GraphQL schema aligns really well with the data model that the underlying database offers. And as Neo4j is open source and quite extensible, it's pretty easy to build an extension. How hard can it be? So as I said, it aligns pretty well. And also the transformation from GraphQL queries to Cypher queries was actually pretty straightforward because we could create arbitrarily deeply nested Cypher queries from every GraphQL query. So there was no need for multiple queries, multiple fetches, but we could just generate one single query and run this against the database, return the results, and we were already there. It actually got easier with Kotlin, so thanks a lot to the folks from JetBrains, because there's a lot of functional processing going on and so on. So I want to introduce Neo4j GraphQL, the Neo4j extension that makes Neo4j a native GraphQL backend. What can it do? It has a basic auth built in. You just have an endpoint to query against. You can post your schema file against this endpoint and then run queries with parameters against that, get the results back. That's kind of the basic features. But what's actually really cool is that it generates a single query for your whole complex GraphQL query. It also has auto-generated mutations. So for all your types, you get at least create, update, and delete mutations, and have support for all these things, including relation, which is really important for us. You can look up by any fields, fragment support, and I already mentioned the unlimited nesting. So even if you have a really complex GraphQL query all the way down, turtles all the way down, it just generates a single query for that. But the actual power feature comes from combining GraphQL using a directive with Cypher, because then you can create something like computed fields, where you have in your schema definition, you have a field which is annotated, and then this part of the query that is in the directive will be kind of merged into the generated Cypher query and just executed as part of the query execution, and will compute data on the fly that is actually not part of your main model. And the same thing is also possible with custom mutations and queries. How can I use it? Of course, regularly npm install and Neo4j GraphQL with your schema. And it would look like this, if I really quickly can show this. So you just install it, run the thing with your schema. It spins up an automatic Neo4j sandbox instance in the cloud using a Docker with the schema that you provided. Here's the example of a simple movie schema with actors, directors, users, and ratings. And it uses the Neo4j sandbox to spin it up. And when the sandbox is connected, you get a graphical integration as well. It connects to that, and then I can run my custom mutations against the endpoint to create data in the database, and then run the queries against it to create the data, of course. And the really nice thing is, of course, that you don't just get the GraphQL endpoint, but you also get a full-fledged transactional graph database for that. So whatever else you want to do, like recommendations, complex document management, or other things, is also possible. And some things that we also added to that is that you're able to actually inspect your schema visually in the graph database, so you kind of have a means of calling GraphQL.schema in the database, and then you get a visual graph representation of your schema. This is the pretty simple schema. And then, of course, you can also see all the data that it created with the mutations here. It looks like this, and we also saw that. And this is kind of the superpower, where we can just annotate any top-level fields, any mutation, and any query type with a directive, and can add like this superpower to it if we want to. You can find it on GitHub. And we have many questions, so if you like to help us to understand what you want of GraphQL, what we can do better, what's wrong in our thinking, please come to us, talk to us. We love to learn. And this was an experiment that we did, and I'd love to get some feedback on it. We also have this hackathon where we put the whole GraphQL community, so all your tweets, all your meetups, all your Stack Overflow questions, all your GitHub projects into one large Neo4j database, put the GraphQL frontend in front of that, and offer you to win some stuff at a hackathon if you either use the extension to query that, or if you build a small application or component against that. And of course, as everyone else, we are also hiring, so we are looking for React developers who help us to build the most awesome graph interface possible. So if you are interested in that, then please come and find us and talk to us. Thank you.